Beyond silicon, the rise of living AI chips that could change computing forever. Intro, setting the stage. What if the future of artificial intelligence didn't come from silicon at all, but from living neurons? Not a metaphor, not science fiction. A real, functioning biological chip that learns, processes, and evolves, just like the brain it's modeled after. It's called Bionode, and it's not just disrupting GPUs, it's reshaping how machines will think, adapt, and even grow in real time. Backed by a startup named Biological Blackbox and supported by tech giant Nvidia, this breakthrough isn't just an innovation, it's a paradigm shift. In this video, we'll unpack how this living chip works, why GPUs are struggling to keep up, and why Bionode may usher in the most radical transformation in AI computing history, the GPU bottleneck. Why current chips are breaking down GPUs have powered the AI revolution. From training massive language models to generating hyper-realistic deepfakes, companies like Nvidia and AMD have been the backbone of modern AI. But there's a growing problem. These chips are reaching physical and environmental limits. As AI models scale up, so does energy consumption. Training a single large model can emit as much CO2 as several cars over their lifetime, posing serious environmental consequences as AI adoption spreads. And the architecture itself is flawed for adaptation. GPUs process data in linear chunks. They aren't built to learn on the fly or restructure based on new inputs. They need constant retraining, which means more data, more energy, more time, and massive computational overhead. That's why researchers are now exploring biological computation, not as a gimmick, but as a necessity to overcome the bottlenecks AI is starting to hit. Meet Bionode, a living AI chip made from neurons. Enter Bionode, a processor made from lab-grown neurons cultured from human and rat stem cells. Created by Biological Blackbox (BBB), this chip doesn't use transistors or circuits. It uses biology, and that changes everything. The neurons are grown in a dish that contains nearly 500 electrodes. These electrodes act as the bridge between biology and digital input, allowing real-time interaction between living matter and machine logic. The neurons are alive, functioning, and able to respond to stimuli. The result? A processor that can learn in real time and change its own behavior based on data, not programming, something GPUs simply cannot do. This isn't a sci-fi brain in a jar. It's a working prototype used for real-world tasks like computer vision and language processing. And unlike traditional chips, it doesn't need frequent retraining. It just adapts quickly, efficiently, and organically. How the Bionode works: biological architecture in action. Let's break it down. When data, say an image or sentence, is input into the system, it's translated into electrical signals. These signals travel through the neuron network like synapses firing in a human brain. The neurons don't just passively receive data, they process it dynamically. They rewire themselves, adjust to signal patterns, and create new pathways. Just like a human brain learning a new task through repetition, the output is then captured by the electrode array and converted back into digital signals that the machine can understand. This feedback loop enables two massive advantages: continuous learning. Unlike GPUs, which need retraining for new data, Bionode neurons learn naturally and autonomously, adapting with each input stream and improving over time. Low power consumption. Biological neurons use a fraction of the energy GPUs need, making them incredibly efficient, especially for real-time, edge, or mobile AI applications. And these neurons can live and function for over a year in stable lab environments. That makes them viable for long-term, real-world deployment in sectors like robotics, smart health, and environmental monitoring. Nvidia's role in the hybrid future of AI hardware. Rather than viewing Bionode as competition, Nvidia has embraced it. BBB is a part of Nvidia's Inception program, a startup accelerator designed to integrate cutting-edge tech into the Nvidia ecosystem and future hardware roadmaps. The vision isn't to replace GPUs completely, but to augment them and build systems that combine strengths from multiple architectures. Imagine a hybrid system. Biological chips handle adaptability and learning, creating human-like responsiveness in unpredictable environments. GPUs handle mass data processing, making fast calculations and large-scale model training possible. CPUs manage general operations like communication, control, and software execution. And in the future, quantum processors will handle ultra-complex simulations and probabilistic reasoning. This layered architecture would allow AI systems to evolve, learn and deploy in real time without constant retraining cycles, data center dependency, or massive energy waste. Real-world use cases. What the living chip can already do. BBB claims that the Bionode has already shown performance benefits in computer vision, acting as a pre-processing layer. It reduces the GPU's workload, speeds up inference, and increases accuracy. Language models. It provides a dynamic update layer for LLMs, allowing them to adjust to new data without retraining the whole model. These use cases are critical for industries like robotics, healthcare, and finance, where data changes constantly and decisions must be made in milliseconds. In robotics, for instance, Bionode chips could allow machines to adapt to new environments in real time without needing a data center connection. Ethical challenges of living chips. When you start using living cells in a computer chip, ethical questions follow. BBB is transparent about this. The company emphasizes that Bionode isn't trying to replicate consciousness. These aren't full brains. They're task-specific neural networks with no awareness or self-perception. Still, as biological computing evolves, the boundaries will blur. If we one day build general intelligence from neurons, how should we treat it? Could lab-grown neural systems have rights? These aren't science fiction dilemmas. They're legal and moral debates waiting to happen. For now, BBB is focused on narrow, structured tasks. But the deeper we go into biological hardware, the harder it will be to draw clean lines. Why this is a milestone in neuromorphic computing. Other companies like Intel, with Loihi, and IBM, with True North, have built neuromorphic chips, hardware that mimics the behavior of neurons using silicon. But Bionode goes further. It uses actual biological neurons instead of simulations. That's a major leap. Instead of copying nature, we're now using it. The implications are huge. AI models that evolve without retraining machines that learn like brains, not computers. Hardware that adapts to the environment in real time. This isn't just a new chip, it's a new paradigm of computing. Energy efficiency, the silent revolution. One of the biggest hurdles in AI right now is power consumption. Data centers guzzle electricity, GPUs overheat, and scaling models burns energy on a catastrophic level. Bionode's biological neurons use microwatts of power. That's thousands of times less than what GPUs consume for similar tasks. If adopted at scale, this could drastically reduce the environmental footprint of AI systems, making them not only smarter but greener. For edge computing, such as smart devices and mobile robots, this level of efficiency is revolutionary. The road ahead, a modular, bio-digital AI future. BBB isn't aiming to dominate the chip market overnight. Their plan is slow integration, first into research labs and specialized enterprise systems, then into commercial devices. They're already in talks with partners across fields like medical imaging, autonomous vehicles, smart manufacturing. Their roadmap includes a relocation to Silicon Valley, hiring more bioengineers, and building a long-term infrastructure around hybrid computing ecosystems. If successful, Bionode could be the missing link between artificial and natural intelligence, ushering in an era where AI doesn't just simulate human thought, but evolves through living systems. The future is not fully synthetic. For years, we believed AI would advance through faster chips, more data, and better algorithms. But Bionode suggests something deeper, that the next leap might not come from better software, but from biology itself. In the coming years, we might not just be optimizing code, we'll be growing hardware, training machines not by lines of logic, but by neurons that live, adapt, and learn on their own. And while the implications are staggering, socially, ethically, and technically, the trajectory is already underway. Biological AI chips may not be mainstream yet, but they've crossed the boundary between fiction and fact. This isn't just a revolution in computing, it's the birth of a new species of machine, one that learns as we do, lives in hybrid form, and may soon power the very future of intelligence. If this glimpse into the frontier of AI blew your mind, don't forget to like, share your thoughts in the comments, and subscribe for more deep dives into the wild edge of innovation.